All right, you guys, you want me to do the review with you. So here goes, all right? Number 1, y equals 3 times 2 to the x, and we're going to go y equals log, 3 log base 2 of the x. All right, so they don't have to be perfect, but there's a few characteristics you have to have, all right? So whatever number is here is where it goes through the y-axis, because anything to the 0 power is 1. So all of this is 1 times 3 is 3. So I'm going to go 1, 2, 3. It's got to go through 3. It's exponential, so it's just going to go like that, okay? The log is the inverse of it, so it's, if this goes through at 3 on the y-axis, then the log equation goes through 3 on the x-axis, and it just looks like this. Okay, here's my log equation, here's my exponential, and they are inverses of each other, so technically they have a line of symmetry that goes right down the middle. Okay. Now, if there was no number here, it'd go through 1, hint, hint, hint. Same thing here, it'd go through 1 right there, hint, hint, hint. Okay, anyway. 2, what's domains? We need the domain of this one. Well, domain's actually pretty easy. Domain is what x can be, and it's just x is greater than 0, because it never touches the y-axis. Always has to be greater than 0, okay? The range, if you need the range, it's all real numbers, okay? So that's number 1 and number 2. All right, number 3. Log of 100 equals x. Now there's a hidden base, and of course the hidden base is base 10, so we got a little hidden base of 10 right here. So I'm just going to go and rewrite 10 to the x equals 100. That's all I need. Exponential form. Don't solve it, just put it in exponential form. Okay. B, ln of x equals 7. It has a hidden base also. We would rewrite this as log base e of x equals 7. Natural log means log base e. So I'll rewrite this as e to the 7 equals e to the 7. Sorry about that. E to the 7 equals x. There you go. E to the 7 equals x. It is after school, and I'm tired, but I'll keep moving on, okay? All right, turn the page. Number 4. Well, you're going to have 10 to the x equals 576. Nope, 756. Look at me already. 10 to the x equals 756. All right, it's base 10, so I'm just going to change it to log. Since it's base 10, I'm going to go straight to log of 756, and I'm just going to use my calculator. It's just log 756, and I get an answer of about 7.28, 2.878. Good enough. Okay. 5e to the x equals 22. So if it's e, I'm going to use natural log base e. So I'm going to go ln of 22 because it's base e. I don't know, what's natural log of 22 is about 3.09. Not too hard. Pretty easy. 6. I'm just cruising along because I want to go home. 5 to the x equals 245. So to do this one, I'm going to change it to log form. Log base 5 of 245 equals x. Now your calculator won't do base 5, but you can do the change of log formula, which is going to be x is equal to log of 245 over log of 5. Now the base I'm using is my calculator base, so I can use my calculator. So I'm just going to go, all right, log 245, close your parentheses, divided by log of 5, and I get an answer of about 3.418, which would be 5 to the x. 3, so x is about a 3.418. That would be 5 to the x power to give you 245. 7. Alright, I'm cruising, huh? Well, I want to get this done, so I go home. 3 times 2 to the x equals 636. Alright, divide by 3 first, right? 2 to the x equals, what is that, 212? 636 divided by 3. Yeah, 212. Should believe myself. Okay, I'm going to do the same thing I did in 5. Same thing. I'll do the log base 2 of 212 equals x. Can't do base 2 on my calculus, so I'll do the change of base formula. X is equal to log of 212 divided by log of 2. And I'm going to use my calculator, right? Here we go. Log 212, close parentheses, divided by log 2, and I get an answer of about 7.73. Alright. Alright, you can have the substitute, slow it down, or pause it anytime you want. Okay, number 8. Same stuff. 5 to the 3x equals 89. Let's log it. Log both sides, change it to, if I actually do, you know what, I'm going to do this a little differently. I'm going to take the log of both sides. Log of 5 to the 3x, which would bring the 3x down, right? Equals log of 89. And divide by log of 5, so I have 3x equals log of 89. Divide by log of 5. Alright, so let me use my calculator. Log 89, close parentheses, divided by log 5 gives me a 2.78. Then I'm going to divide by 3, right? So I got 3x equals this 2.7889, blah, 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 blah. Divide by 3, and I get an answer about 0.9296, blah, blah, blah. Okay, 9. How am I doing? Remember, you can always ask the sub to pause it. I'm going to try and get this done so I can go home. Alright, 9. I have a 2 to the x plus 1 equals an 8 to the 2x. Okay, so what I can do is this. I can make 8 into a 2 because I know that 8 is equal to 2 cubed. So I'm going to replace 8 with 2 to the third so they have the same base. So I'll go 2 to the x plus 1 equals 2 to the third with my 2x. Okay, there's still, that is still 8, but now it's in terms of base 2. So it's still base 2, so it really means that this x plus 1 would have to equal this, 3 times 2x. X plus 1 equals 6x. Minus x from both sides, I get 1 equals 5x. Divide by 5 and I get 1/5. Ta-da! Alright. 10. I have log of x equals 3.5. Okay, there's a hidden base. It is base 10. It's hiding down here. And I'm just going to go 10 to the 3.5 equals x. 10 to the 3.5 equals x, and 10 to the 3.5, and I can answer about 2, cannot be right, try it again. 10 to the 3.5, and I can answer about, there you go, 3,162.27. Okay, that was pretty easy. 11 works the same way. ln of x equals 6.5. Again, there is a hidden base. It's base e. It's hiding right in there. So we'll go e to the 6.5 equals x. What is e to the 6.5? I don't know. Let's check it out. E to the 6.5, and it's a pretty big number, 665.14. How am I doing? If we're going too fast, forgive me. Just trying to go home, that's all. 12. I have log base 4 of x equals 3. So I'm going to go 4 to the 3. 4 to 3 equals x. Well, I know what 4 to 3 is. It's 64. 4 times 4 times 4 is 64. All right. Turn the page. We're cruising. 13. Okay. Log base 2 of x plus log base 2 of x minus 6 equals 4. All right, so I need to combine them because this is plus. I will rewrite these logs as a single log. Log base 2 of x times x minus 6 equals 4. Okay, let's just combine them. There's a times sign right here that we don't normally write, but because we added the exponents, it came from multiplying the bases. Okay, let's change it to exponential form. 2 to the 4 equals x times x minus 6. Okay, now this looks like it's fun. Looks like we're going to factor. I like that. 2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16 equals an x squared minus a 6x, right? Bring over the 16. I'll have 0 equals x squared minus 6x minus 16. I need factor. I like to factor x and x. Let's see, how about a negative 8, positive 2? Okay, now that is not the answer, though, because we're going to solve it. So I really am going to get 0 equals x minus 8 and 0 equals x plus 2. One answer is 8, because I added the 8. The other is negative 2, but we're going to throw away the negative. You can't have logs of negative answers. That was fun. Okay, let's look at 14. Yeah, I'm cruising along. You can always pause it, back it up, rewind it. 14. Okay, we've got a 1/3 log A plus 5 log B minus a log C. All right, there are exponents first that have been floated down. Bring this exponent back in. Bring this exponent back in, okay? So I'm going to have a log of A to the 1/3 plus log of B to the 5th minus a log of C. Okay, now, plus and minus, single log. We're going to go log of, that's a cube root of A times B to the 5th, you don't need the times sign, but there it is, divided by C. There's your single logarithm. Okay, you don't need the times sign, it's implied, but that explains the plus. Okay, 15, we're going to go just the opposite. We got log base 3 of x squared, the 4th root of y divided by z cubed. All right, so we're going to go times makes plus, divide means minus, log base 3 of x squared, okay, plus, because the times, plus log base 3 of the 4th root of y, minus because the divide by log base 3 of z cubed. Okay, last thing I'm going to do is float the exponents down. Now, the 2 is going to come down. Now, this has an exponent, but it's an exponent of 1/4. So I'm going to float that down 2, and I'll float down the cubed. Okay, so my final answer, 2 log base 3 of x plus 1/4 log of y minus 3 log base 3 of z. That is expanded form. Okay, we're almost done. Can't believe it. 16. And you can ask the sub to pause it anytime you want. Back it up, okay? Okay, a cell biologist needs to grow 100,000 cells. We need 100,000 cells in the end. In the end. She starts with 100 cells. That's the beginning. N of 0. Okay? And it doubles, I'm going to circle that, every 5 hours. Alright, so let's see if we can find that doubling formula. So it's something like Oh, n of t is equal to n0 times 2 to the t over a. All right, that's the formula I think we learned in our notes. That's the one I want. So, 10,000 cells. So let's first set it up. We'll have our beginning amount, which is going to be 100. 2, because we're doubling. T to the cycle time, which is 5, okay? So we start with 100, it doubles, and doubles every 5 hours. Okay, now what we want to do is find the time that it takes to grow 100,000 cells. So let's solve. Step 1, divide by 100, take away 2 zeros. So I got 1,000 equals 2 to the t over 5. And since I'm going to need to bring the exponent down, I'm going to take the log of it. So I'm going to take the log of each side, the log of 1,000, which is 3, by the way, is equal to t over 5 log of 2. Okay. Now, log of 1,000 is 3. It's a special one. You can use your calculator if you don't believe me, but it turns out to be just 3. Okay. T over 5 log 2. All right, to solve then for t, I'll multiply by the 5, and I get 15. All right, bring up the 5 equals t log of 2. Now we'll just divide by log of 2. So 15 divided by log 2 equals t. And I'm going to use my calculator, right? Let's see what I get. 15 divided by log 2. Oh, turn it on, that helps. Helps me a lot. Okay, 15 divided by log 2, and I get an answer of about 49.8. And that must be in terms of hours, maybe. Hours. Because it doubles. And man, I tell you, it grows fast, doesn't it? Okay. So here's a. Here's my exponential function right here. There's a, and here is b. All right, 2 more questions. We're almost done. All right, 17. Seborgium, that sounds like a funny sounding stuff, has a half-life of 4.34 minutes, which means it's pretty unstable. Okay, that's my half-life. So the scientist has created 10,000 atoms in a lab. Okay. And it's going to start to fall apart real quickly because it's highly unstable. So find a half-life function to model this. So let's use our n of t equals our n0 1/2 to the t over a. All right. Beginning amount, which is 10,000, 1/2 because that's the rate at which it grows, and a is my half-life, okay, which is 4.34. So our formula. N of t, number over time. Beginning amount, 10,000 atoms, 1/2 to the t over 4.34 minutes. Okay, there's A. We got our formula set up. Boom. B. How long will it take for only one atom to be left? So we're going to set it equal to 1. 1/2 t over 4.34, and we're going to solve, okay? So divide by 1. 1 divided by 10,000. Well, let's see, that's probably going to move the decimal a few places, right? So what we get is 0.0001 if we divide by 10,000. 10,000, right? 1, 2, 3, 4 zeros, 1, 2, 3, 4 equals, you can do it on your calculator, if you don't believe me, 1/2 t over 4.34. Okay, so I just divided by 10,000. That's it. Log both sides because I need to float the exponent down. So we're going to take the log of both sides. So the log of 0.0001, and that should be -4. What do you think? Let's check it out. Pretty sure the answer is -4. So this is just -4 equals t over 4.34 log of 1/2. Okay, back up. Took the log of both sides. Took the log of both sides. Floated that down. Now, from here, this is actually a really easy number. This is just plain old -4. Check it out on your calculator if you don't believe me, okay? 4.34 log of 1/2, okay? Multiply that up times by 4.34, and I get an answer of -17.36 is equal to log t, log of 1/2. Divided by log of 1/2. Divided by log of 1/2. What's t equal? Use my calculator. See that? Yeah, I'm just going to take it and divide that by log 0.5, and I get an answer of 57.66. It's going to 57.66 minutes, a little under an hour. Minutes for it to dissolve down to 1 atom. Okay. Whew, last one. And this is an easy one. 18. All right. Intensity equals log of, no, sorry, my bad. Magnitude equals log of my intensity over my initial intensity, all right? Okay, so we found out that I of 0 is a standard intensity, and that's going to be 10 to the -4. Okay, we're going to put that right there, always. So find the magnitude with an earthquake seismology reading of 4.4. So that's my intensity, is my 4.4. So I'm going to go magnitude equals log of 4.4 divided by 10 to the -4. And I'm just going to use my calculator. I'm going to go log 4.4 divided by 10 to the -4 power, and I get an answer about 4.64. So it's a magnitude of 4.64 on the Richter scale. How's that? Okay, I'll be back tomorrow, and we're going to rock and roll on this test. You're welcome.